In this video, I'd like to talk about evaluating variable expressions with exponents. So essentially, we're just evaluating expressions here, but some of these expressions are going to have the variable in the exponent. But if you remember the video from evaluating expressions, we're essentially just going to replace x anywhere we see it with the value of 3. So let me just rewrite our expression. We have 4x divided by 2x, and then we're going to plug in x is 3. So anywhere we see this x, we're going to replace it with the number 3. So let's do that. We have 4 to the x, which is now 3, divided by 2 to the x, or 2 to the third. And at this point, you just want to remember your basic definitions for exponents. What does it mean to raise something to the third power? So 4 to the third power means take this number and multiply it this many times. So 4 to the third just means 4 times 4 times 4. And likewise, 2 to the third is this number multiplied that many times. So 2 multiplied 3 times. And we just have to simplify this. So 4 times 4 is 16, and 16 times 4 is 64. So you get 64 up top, and 2 times 2 is 4, times 2 again gives you 8, and 64 divided by 8 is simply 8. Now you could make some simplifications along the way, since 2 and 2 make 4, so these can cancel out with this. And then it's just a little bit easier. You can even simplify even further, since 4 divided by 2, you can make that a 1 and this a 2, and then 4 times 2 is 8. So however you want to solve this is fine, but the end result is that you get 8. And again, the general strategy is you're just going to replace your x value with this value of 3 and then just simplify. So let's move on and work through several different problem types. So in this one, we have 7 squared divided by x squared minus 2. So let me just rewrite this. 7 squared divided by x squared minus 2. And this time we're going to say that x is 3. So we're going to use the same value, but just a different expression here. And when we plug this in, we're going to replace x with 3. So we have that 7 squared divided by 3 squared. Since we had x squared and we replaced x with 3, so 3 squared and then minus 2. And 7 squared, so this number multiplied twice, so 7 times 7, divided by 3 squared, which is just 3 times 3, and then we have minus 2. So 7 times 7 is 49. 3 times 3 is 9, minus 2, so that'll simplify to 7 in our denominator. So from here we have 49 divided by 7, but 49 divided by 7 is simply 7. So in this case, you would put the number 7 into our box. So let's move on to another one. And this time we have 2 to the x, so I'll rewrite it, minus x squared. And this time we'll plug in x is 5. So anywhere we see an x, we're going to replace it with 5. With that in mind, we have 2 to the x, or 2 to the 5th, minus x squared, or 5 squared. And so 2 to the 5th, so it's this number multiplied 5 times. So 2 times 2 times 2 times 2 times 2. And then minus 5 squared, so this number multiplied twice, so 5 times 5. And 2 to the 5th, so let's do it in pairs. So 2 times 2 is 4, times 2 again is 8, times 2 again is 16, and doubling again is 32. And 5 times 5 is 25. So 32 minus 25 would give you 7. So 7 is the value you'd put in the box here. And let's do a different problem type, though it's still pretty similar. We're evaluating these expressions with often variable exponents. And so we're going to plug in x equals 2 to each of these and then figure out which of these values should go where. So in the actual exercise, you'll be able to drag and move these around. So let's start with x to the 5th. And for all of these, we're just replacing x with 2. So that would be 2 to the 5th, which we did above in the last problem. That was 32. Because remember, it's just 5 2's multiplied together. So this one would be 32. I'll use a darker color for that. And now we go to 8 to the x. And again, we're replacing x with 2. So we get 8 squared. And 8 to the second just means 8 times 8. This number multiplied twice. And that's 64. So 64 should go here, which tells us by process of elimination that this should be 16. But we're going to double check it just to make sure. So x to the fourth, replacing x with 2, we get 2 to the fourth, which is just 2 times 2 times 2 times 2. So it's 2 multiplied 4 times. And 2 and 2 make 4. So each of these is 4, and 4 times 4 is 16. So we can confirm that this was in fact the right answer. So basically on the actual exercise, you would just have to switch these, and then you'd get it right. All right, let's do one more like that. So now we're going to replace x equals 3 for each of these. And let's look at the first one. We have x cubed, so that will be 3 cubed. And 3 to the third is just 3 times 3 times 3. We're multiplying 3 times. 3 times 3 is 9, times 3 again gives you 27. And then for 4 to the x, we'll replace x with 3, so you get 4 cubed. And so this number multiplied 3 times, so 4 times 4 times 4. We did this above. 4 times 4 is 16, times 4 again gives you 64. And then lastly, you have x to the fourth, and replacing x with 3, so you have 3 to the fourth, which is just 3 multiplied 4 times. 3 and 3 make 9, so 9 times 9 gives you 81. So let me now put them in their proper places. So this first one, x cubed, this would be 27, so that has to go up there. 4 to the x, that would be 64. So these are switching. And then this bottom one is correct. This would be 81.